Welcome to SICSS-Covenant tutorial series. I am Emmanuel Olamjimo, and it's my pleasure to introduce our tutorial lead for this session, Dr. Laurie Baker. Dr. Baker is a certified RStudio instructor, and the core of our research focuses on spatial and temporal patterns in human and biological systems, including disease spread, animal movement, and fishery management. Today, she will be introducing us to spatial data and leaflet mapping in R. Thank you very much for joining us, Dr. Baker. The virtual stage is yours.
Thank you for the nice introduction. So I'm a marine biologist by training. I then did my PhD in epidemiology. I'm also a certified Tidyverse instructor with RStudio, and my research institute interests span public health, ecology, and also data science. I've recently accepted a position at College of the Atlantic in Bar Harbor, Maine in the US, where I will be teaching computer science and data science to undergraduate students. And you can find out sort of more about me and some of the work I do on my website, Twitter, and also my GitHub account. So in terms of what we'll cover today, we're going to have an introduction to spatial data and working with spatial data with the SF package, which stands for Simple Features. We're going to cover how to build a map using ggplot2. And what we're going to see is that actually building a map in ggplot2 is very similar to how we're going to be building our maps eventually in Leaflet. We'll then go through coordinate systems and geospatial objects in R. And looking at how we can check these and also inspect like our geospatial data. And then we'll cover how to build interactive maps using Leaflet. And for this, I'm going to cover two examples. One is going to be looking at how we can build maps that include administrative areas. And then another example is going to be using data sets where we have latitude and longitude specified, which are some of the common data sets that we'll have. Just going to refresh the page. Okay, super. So in terms of what we'll be using in terms of packages, we're going to be using Tidyverse, which is for plotting and data wrangling. Leaflet is the main library that we're going to be using to build the interactive maps. The SF package we'll be using for working with the spatial data. Our color brewer is a library that's really useful for picking out color palettes. And then when we're adding labels to our maps, we'll be using the HTML tools library. We also have the option to use the library LeafSync if we want to display two maps side by side, and I'll go through that in the slides. We're also going to be using the stringr package for some character string manipulation. So as we clean up names and as we match administrative boundaries. And then we'll also use the library rgeoboundaries, which is one of the ways that we can access geographic administrative boundaries for different countries. And then we'll be using the cable extra package, is used both in the slides and then in the tutorial as a way to display our tables. Okay, so a brief introduction to spatial data. So the first is that everything happens somewhere. And we represent spatial data in a variety of different ways. So commonly we'll use points, lines, polygons, and rasters. Examples of points would be any GPS location that we have, which is usually specified by a latitude and a longitude. An example of a line would be like roads, or we might have sort of train lines. And then polygons, an example of polygons would be like the administrative boundaries we have for countries, but also for regions within a country. We're not going to talk as much about raster data today, but raster data is another common data type where we might get gridded population data, or we might also get environmental data, such as temperature. that would come in a raster. If you want to turn to your neighbor and think about a couple of examples from your own research where you see sort of point, line, and polygon data come up. So I'll give you a kind of minute or two to talk to one another, but what are a few examples you find in your own data where you see these spatial data types come up? So we work with a lot of this data sort of every day, and especially when we're involving locations. So one of the things is that when we're working within the SF package, we have a couple options for how we represent these data types. So points are always going to be represented as either a point or a multi-point. So multi-point is just going to be several points. The same with lines. So lines are often represented by line strings and also multi-line strings if there's many of them. And you often use line strings as well when you're looking at networks. So for instance, if you're looking at the connectivity between different cities, which you could measure in terms of like the flow of people sort of traveling between those places, that could also be an example of a line string. And then for polygons, you can have a single polygon or you can have multiple polygons. So often when we're working with, say, country data where there's an island or several smaller administrative regions, those would be most often represented as a multi-polygon. So now each of these things, when we're looking at something like a line string is also going to be made up by at least 2 GPS coordinates, and then you just have a line connecting them. And similarly, when we're talking about countries and regions, they're also a set of GPS coordinates, and they're giving the outline of the country, and they always start and end in the same place. So while we're working with these shapes, underneath all of them is actually the GPS coordinates that give the outline or show sort of what the line looks like. So we're going to be working today with a data set on North Carolina, and it's from within the SF package, and we can access it using st_read. st_read is the function that we will use whenever we're loading in geographic data. So the way that we do this is we're going to call our data object something, so we could call it nc_df, and then we'll use the function st_read, this system file, and then the shape nce.shp. It's coming from within the package, so that's why the code looks like this. If we were just including a shape file that was on our own computer, we would put the path to that file. So for instance, if I had a file, a shape file for the state of Maine, my file might be called something like main.shp. So the st within the st_read function stands for spatial type. And then the .shp is a common geographic shapefile format that we'll be working with if we work with ArcGIS or QGIS. Oftentimes the shapefiles will come in this format. So if we hop over to our Studio workspace or our Studio Cloud, we can go ahead and open up the assignment. There might be a banner that asks us to install and update some of the packages. So we can do that, but we can start by running like the first lines of code. And I'm going to show you where to find the tutorial. So if we go to the project, and if you open up the GitHub repository, let's make this a little bit bigger. If you open up the GitHub repository, what you're going to see is you're going to see a couple of different folders. You're going to see a folder where the slides are. You're also going to see another folder that has the tutorial. Now, if you click on the tutorial, you're going to see a couple files here. One has a list of all the packages to install. And then we also have the leaflet_tutorial.rmd. If we open this, by clicking on it, it's going to open up our leaflet map tutorial here. And I'm just going to walk you through a couple of different things within the R Markdown file. So one of the nice things about working with R Markdown is that it allows us to mix both our code and our text together. And our code is specified in these small code chunks. So the first one we have here is our package installation and also where we're loading the package. Now, at any point during the tutorial, if we want to run one of our code chunks, we can press the play button, the green play button here on the side, and that will go ahead and it will load all of the packages that we're using. So I'm getting a message saying there's no package called RGO boundaries. And so for this one, I will need to install it using this remote install _ GitLab. And so I can go ahead, and if I just want to run one line of code, I can do control return. And I also will need to install the remotes package. So I can do install that package as remotes. That's going to install the remotes package, which allows us to install different packages from GitHub repositories. And then next, I'm going to go ahead and run this one again. And this is going to be downloading the GitLab repo from Amadou Diko's GitHub. And the RGO boundaries package is going to be the one we're going to use later on in the tutorial when we're accessing the administrative boundaries. So we can go ahead now again and just run that again. All of our packages are loading. And then now we're in this next code chunk where we're loading in the North Carolina data set. So we can go ahead and run this code chunk. And it's going to give us some information about the data set. So North Carolina is a state in the kind of like south of the US on the coast. And here we can see we're reading in the layer and see from the data source. We're using the driver. A little bit of information about the data set. So it's telling us that it's a collection with 100 features and 14 fields. So these 100 features actually represent each of the rows within our data set. And each row is representing one county, which is one of the common administrative units that we have within the US. And the 14 fields are 14 data columns that we have in our data set. It's going to tell us that the geometry type is a multi-polygon. And it also gives us this bounding box, which gives us a series of the latitude and longitude coordinates that make up sort of what area of the world we're looking at in terms of the latitude and longitude. If we want to inspect our data set, we can click in the environment window and press on the data set, and this will open it up. So what you can see is that we have each of our rows, and then we have an area, a perimeter, we have a county code. We've got the name of the county. So the first county is called Ashe County. We've also got some other different codes that would be used for some of the administrative boundaries within the state. And then we also have some information here. So we have the number of births. This is births, BIR 74 is the number of births within that county from 1974 to 1978. And then this particular data set is actually looking at the number of sudden infant death syndrome, which is when a child dies like early on in its infancy. And we're looking at, it's got a set of data for both of those. And then we also have the births in 79 to 84, and we also have the number of sudden infant death syndrome deaths for that period as well. Now, what you're going to see is that anytime we're working with the SF package, we have a geometry column. And remember before when I was saying that each of our each of our regions that we have is actually just a series of latitude and longitude coordinates. So this list here that we have for the geometry is actually giving us sort of all of the points. So if I hover over it, you can see that there's a number of different sort of coordinates. We're getting sort of a series of first the longitude coordinates and then the latitude coordinates. And this is essentially giving us our outline of the administrative region. So what you can think of is that the way the SF package is set up is that it works with things as a data frame so that you have each of your variables in a column. And then that geometry is going to be associated with a particular county or administrative region, and it's giving the sort of outline of that county. So hopefully we're all sort of set in terms of running those first lines of code and introducing our data. One thing to keep in mind when you're working with your own files is that usually when you're working with outputs from Esri, you have not just a .shp file, but you also have other types of files like .shx and .dbf. They all need to be kept together. So when you upload a spatial file into R, you'll want to keep all of the sort of files that are associated with the file in addition to the .shp file, which is the one that you would call. Okay, so the next thing we're going to be doing is just renaming some of our variables and only keeping the columns that we want. So here I'm taking the North Carolina data set, and I'm just selecting the column that has the name of the county, the births from 1974, the births from 1979, and then also the geometry column, which is where we have our spatial data. And then I am just renaming these columns using the 1974 and births in 1979. In this case, we're using the tidyverse syntax, so that whenever you see the pipe symbol, which is a percentage greater than percentage sign, you can always think of it as meaning and then. So it's a way of you combining multiple functions into, I always like to think of it as like a factory assembly line. And what this allows you to do is you don't need to make sort of intermediate sort of using the tidyverse package. Okay, so we've loaded in our data, and now we can take a look at the first 6 rows using the function head. So here you can see that we've got now the county, and then we've got the number of births in 1974, and then the number of births in 1979, and then we've got our multi-polygon. So we're all set now to start to visualize our data. But first, one of the things we want to do is just inspect the structure. So we can check the structure just like we would check the structure of a regular data set by using the str function. And it's going to give us a summary of each of these things. So one of the things we can see is that the county are a character data type. And this just means that we have the name of each of the counties. We can see that births is numeric. It's giving us the number of infants that were born within that county. And then we can see we also have some further information about the geometry. The other thing we want to pay attention to here is that you can see that up at the top, we've got classes, our SF, and also data frame. So especially when we're getting ready to plot spatial data, we just want to see that it is being identified as the SF type. Because that'll give us, make it so that both ggplot and also Leaflet are going to be able to work with our data. Okay, so where we are up to in the project is we're down sort of at this point where we've just checked the structure. Anytime we want to run all of the code chunks above, we can use this upside down play button, and that will run everything that came before. So it's run the head, and then we can also go ahead and run the structure. And then we're all up to date with our slides. So now if we're plotting a map with ggplot, ggplot always builds plots up in layers. And so they'll first start with the data set and a call to the data set. So it'll start with ggplot. We then specify the name of our data set, which in this case is NC for North Carolina. We then are specifying the geom. So the geom is going to be the geometric shape that we're going to be using to display our data. So often when we're making plots with ggplot, we might have something like geom point. If we're making a point plot, we could have geom line if we're making a line plot. The geom that we'll use for working with spatial objects that are of an SF type is the geom_SF. So already you can see we have all 100 of our North Carolina counties. North Carolina is one of the states on the coast, so we can see we have some interesting kind of coastal features here. And we have each of the outlines of our administrative boundaries. And the way that the geom_SF is creating this map for us is it's looking into that geometry column. And by those GPS points, it's able to trace out the shapes that we have in there. Now, the next thing we can do is we can specify colors for our plot using the aesthetics. The aesthetics are going to be things that relate to the data. So for instance, here we've got geom_SF, AES fill equals, and then we can specify like our column name. So if we go there, we can specify equals first 1974, and we can give it the name of one of our columns. So you can play around here with trying either like births 1974, or you could try also like births 1979. What we can see is that it's automatically creating a legend for us. And we're seeing that the number of births in North Carolina, they range from about sort of, small numbers all the way up to about like 23,000. And the color gradient that we're getting, the lighter it is, means the more births we have in those counties. Like the fill. We can then add labels. So we can add another layer to our plot where we specify the labels. And in this case, I'm adding a label for the title of the plot. So I'm saying births for county 1974 to 1978. And then I'm also adding a label for the longitude and also the latitude. And I'm also updating the legend label so that I've got like the number of births. And the way that we add these different layers to our ggplot is we will do it using the plus. So anytime we're adding a layer within ggplot, we're going to be using the plus to add on another pip. The other thing we can do to customize our plot is we can add scales. So scales is a layer that is going to be specifying the aesthetic that we're changing. So in this case, the Y is going to be for the y-axis that's showing latitude. And if we look at the previous plot, we can see that actually the latitude, there's a lot of labels and it looks a little bit sort of busy on this side. So one of the things we want to do is that when we add, we can specify like the different breaks that we'll have. So I'm setting them from 34 to 36. And so it's just going up by 1, and it just tidies up our labels like just a little bit. So we can use scales to customize our plots to change things like the range. And this would be sort of how we are going to be working with sort of making plots with ggplot, which is going to be helpful anytime we need to create a static plot, especially for including in like a PDF or a report. Leaflet is a tool that only works when we're connected to the internet and we can use an HTML document. So one of the things that we can do for accessing administrative boundaries is there's a helpful package called the RGeoBoundaries package that works with the GeoBoundaries API. So if we wanted to get the outline of Nigeria, we can access it using the GeoBoundaries function. And so we can store that into a new data set that we call Nigeria. We then are specifying GeoBoundaries and we do country equals Nigeria. So we can put the name in there. And then we can go ahead and we can make our first set of ggplot. So we can do ggplot data equals Nigeria plus geom_sf. And this is going to allow us to get the outline of the country. So it depends on sort of what level we have our data at. We might want to sort of get things at the department level, or we might also want to get more countries. So for instance, if we were interested in looking at Nigeria and Chad, the way that we would change our code is that we would just specify the name of the countries we want separated by a comma. So here we've got country equals, we're using the C function, which stands for concatenate, to combine two names. And then we've got Nigeria, comma Chad, and Nigeria, comma Chad. And then we can go ahead and make our plot with the data set. Okay. So then we can go ahead and make our plot by doing ggplot data equals Nigeria underscore Chad, and then we can do the geom_sf. And now we have the outlines of both countries. Now, if we want to have the administrative levels at a more detailed level, we can specify an additional argument to our function. And this argument is called admin_level. And we can see, oops, got sensitive slides. We can see that we can set this here to admin1. So as we go down, the country boundary is admin level 0, so it'd be ADM0. ADM1 is going to be giving us the departments within the country. ADM2 would be giving us a more detailed administrative level. And then ADM3 would give us an even more detailed level. So we can go ahead and do that. In this case, I am going to be just going back to my original data set. I'm going to resave it onto that same name, because I'd actually like to work with the data at the department level. And then I'm going to make a plot and I can sort of see how those are working out. So how to access the administrative levels and a little bit more about this, you can find out in these tutorials at rspatialdata.github.io, which is a joint collaboration with Paula Moraga and several students who have worked with her at the King Abdullah University of Science and Technology. But it's very handy for getting different levels of administrative data. Now, just like before, we want to inspect the data. So all of these names are probably going to be a lot more familiar to you, but here we have the shape name, which in this case, I'm guessing is the department name in Nigeria. We then also have some additional information about the shape ISO, the shape ID, and the shape group, and also the shape type. And then we have the geometry, which has our multi-polygon. So again, it's a series of latitude and longitude coordinates, and it's giving the outline of each of those boundaries. So in terms of where we are now in the code, you can see that we've created our ggplot. So we can go ahead and jump down to here. I'm going to run everything above just so that I'm up to date. And then I'm going to go ahead and run this next one where I'm getting to the administrative boundaries. And if I want to view that data set, I can go ahead and I can look at it using cable to output my table. So one of the common things that we have is that we often get our spatial data from a spatial file, either through something like ArcGIS, where we download a .shp file, or something like our using the GeoBoundaries package, where we can download that data. But then often we have another data set that we want to work with. So for instance, we might have population data, or we might have economic data, or we might have health data that we want to associate with those administrative regions. And just like we did for the North Carolina plot, where we're looking at the number of births, we would also like to be looking at and customizing our map based on another variable. So currently, if we look at our data set, we really just have the name of the department, and we have the geometry associated with that. So what will happen is that if we have another data set, so for instance, in this case, we've got some population data that we'd like to match to our data set, you can see that we have some different columns. So we had the administrative level 0, the name of the country. We have the country code. We have the administrative unit 1 name, which would be our department. And then here we've got different counts for the population. So this is the number of females in total within our department. And then we've got the number of males in total. And then here we've also got the number of people in total within that department. And then you can see that we also have a lot more detailed population data. So we have the number of individuals between the ages of 0 and 4, 5 to 10, et cetera, as we go up. So if we want to be matching these two data sets together, what is like the common information that we have that we could use to bind the two? So what is it that both of the data sets have in common? So we have the department name that we can match up. So here we've got admin 1 name, and then we've also got here the shape name. So we've got two columns that we can work with. One of the things we can see that's going to be a little tricky is that this one has the name in all capitals, and then this one has the name not in all capitals. So it's got it just the first letter uppercase. So that's going to be something that is going to become important, because one of the things I always tell my students is that computers are very stupid. They are only going to be looking at things for exact matches. So for instance, we can see that the first row in this data set is the same as the first row in this data set, but the computer is going to see those as two different things, because one is with a capital A and then a lowercase BIA, and then the other one is all capitals. So we're going to have to work with the data when we're going ahead and matching it. So we can match names on the administrative boundaries, but we're going to have to do a little bit of cleanup. So one of the ways we can do this is we can take our Nigeria population data and then mutate creates a new variable. It can also replace a variable. So what we're doing here is we're taking the administrative 1 underscore name, and then we're equals, there's a handy function that comes from the string R package that is called str underscore 2 underscore title. That is going to change our names to the title case. And the title case just means that the very first sort of part of the word is going to be capitalized. And then we also put a locale. In this case, we're going to be doing the locale is equal to English, but there's also options for other languages within the string R package, so that you could, depending on the language that the data set is coming in or the name is coming in, you could sort of adapt it that way. So one of the first things is we want to see sort of, okay, we've changed our data set. We want to see how well they match up. So one of the things we can use is a function called an anti-join. An anti-join is going to tell us where our data sets aren't matching. So to do this, we specify the name of our first data set, which we refer to as data set X. So we refer to the Nigeria data set. The Y, we refer to the Nigeria POP, the Nigeria population data set. And then in this by, we have to put what the names of those columns are, where it needs to be looking for the matches. So in the Nigeria data set, it was called shape name. In the Nigeria population data set, it was called admin 1 underscore name. So when we do this, we can see that actually most of the regions are matching. The only one that's not matching is that we have a discrepancy with the shape name for the department Aqua, and then EBOM. So we need to be able to fix that one. And I don't think it's EBOM. I think it's with an L. So that's one of the ones that's not matching up. So anti-joins are really useful at seeing sort of where a discrepancy might be in our data. So that's not a problem. So one of the things that we can do is we can go ahead and we can look And I'm just making a new variable here for that, that administrative region. And I can use something called a case when. So what a case when is doing, it's saying, okay, when the administrative name is equal to the one that's not matching up, we're going to change it so that it does match the case that the other one's in. So what we're doing is we're taking that, that I, and then we're changing it to an L. And then if it's any of the other ones, so if the administrative name is not equal to AKWA capital IBOM, then we can just leave it as the administrative one name that we had in the first place. So it would look in that column and it would just sort of replace each of those rows with the same one. So once we've done that, we can go ahead and do what we call a left join. So left join is going to take our data set X and it's going to join on our data set Y. And it's going to be looking at the two columns, shape name and administrative one name. And where it finds like the match, it's going to be matching those up together. So we can use the case when just to sort of help us with fixing that one element. And then we can go ahead and match them up. And then now at this point, we're ready to create our map. So just in the same way that I was working with the North Carolina data set, here I've specified that the data equals Nigeria underscore DF. And then here we've got GM underscore SF. In this case, I'm going to use the fill as the total population. And then I'm going to add also some labels. So I'm going to add the longitude and the latitude, and then also the total population. And so we can see that this region in particular up in the north is highly populated. This region down here in the south is also highly populated. And we can also see the scale for the population. So it goes from about 0 all the way up to, I guess it would be like maybe 15 million for some of those areas. So am I right in thinking is Lagos down here in the lower left? And then does anyone know the name of the department that also has a very high population in the north? So it could be interesting. And one of the things you can play around with within the file is like, you might be surprised at sort of where the older population in Nigeria is living versus the younger population. So remember, you can change your map to look at any of the different columns. So for instance, we've gone ahead and made our map here, looking at just the total population. But we can also try and see what it would look like if we had another population. So let's go ahead. Okay, we're going to run this one. Then we're going to run the next one. So we're looking at the total population, but we could color this by any of the columns we want. So whenever I forget what the names of the columns are, I can go ahead and put this into here, and we've got Nigeria underscore DF. Okay, so we have, so it might be interesting to look at where we have the most, let's say where we have like the most females from 20 to 24. So we could go ahead and here in our plot, we can just swap that for our fill. So we could go ahead and take a look at this instead. And what's interesting, it sort of is matching, but maybe it's not as sort of high as you would think for other ones. But you can see sort of where maybe things are a little bit lower in terms of where people are. And then you could also do something like looking at the proportion of the total population. So you could do something like T underscore TL. This would be giving us the proportion. So we could go ahead and write that. And then here you can see where it's making up sort of like 5% of the total population in that region or less. So we're seeing sort of like lower numbers. And we would want to also multiply this by 100 so that we get it in times 100. And how's that worked? Okay, we're getting an error. I think I've forgotten one of my parentheses. Okay, so if we look again at our map, go ahead and run that. And we're getting an unexpected symbol in ggplot. Okay, ggplot data. I think we're still having issues here, Phil. Okay. All right, so let's see. Okay, there we go. So this is kind of interesting because we're able to look at sort of what the percentage is of the total population in those areas. So some different ways to sort of explore and to look at things that we can do. All right, so we made our first map using ggplot. Now we're ready to get into learning more about the coordinate reference systems, and then also thinking about making our first leaflet map. Okay, so one of the things is that every location on Earth is specified by a longitude and a latitude. And one of the challenges we have whenever we're working with maps is that we're trying to take a 3D object, which is the world, and we're trying to flatten it down into a two-dimensional surface. And a way to think about this is like if you're peeling an orange, actually trying to lie it flat is very difficult, and there's many ways you can sort of peel it and make it. So we have a lot of different ways that we can do the peeling, and these are referred to as our coordinate reference systems, and they're going to be determining how the data is protected onto the map, how we've taken that 3D object and flattened it to a 2D surface. So we've got another, like several ways that we can do this flattening. These are some of the common coordinate reference systems. So you can see sort of, we can choose to sort of have it as a circle, we can choose to have it as a square, we can have it something that's a little bit more of an ellipsoid shape. All of these things are sort of changing the projection and changing how countries and places appear on the map. And it also really can like play around with the size in which we see things. So this website is a great one for looking at the true size of things. So if you click on the link within the slides, one of the things that we can do is we can go ahead and we can put a country into here. So for instance, if we want to go ahead and take a look at Nigeria, we can type it into here, and then we can drag Nigeria anywhere on the map. So if we look at the total size of Nigeria in square kilometers, it's 923 and then 768 square kilometers. So now because Nigeria is very close to the equator, it actually means that its size looks really reduced compared to other places. So if we were to move Nigeria up to Europe, we can see that actually it's taking up quite a big space within Europe. If we were to move Nigeria up to Greenland, which always looks really big on the map, you can actually see that Greenland is always sort of overestimated in its size. And we can take a look and Nigeria actually looks quite big when we put it up onto Nigeria. We can also look at how Nigeria compares to the US. So for instance, where I live is here in Maine, which is a smaller state, and Nigeria is probably the size of New England or more. And so it's just interesting to look at sort of, especially sort of as countries are getting like further away from the equator, they're looking a lot bigger than they are. Now we can clear the map if we want to put in some different countries. The last one I'd like to show you is to take a look at Brazil. So if we look at Brazil, it's a big country, but it sort of doesn't, it looks like it's sort of about like a little bit smaller maybe than the US from this angle. If we actually move it up to where the United States is, you can see that it actually is quite big. So it's 8,515,000 and then 767 square kilometers. If we move Brazil over to somewhere like Europe, Brazil is way, way, way bigger than all of like Europe put together. And if we were to move it up to sort of Russia, we can see that Russia is pretty large, but actually, you know, Brazil, as we move up into these areas, it's getting very, very big. And so one of the things is that we often use maps and we get used to sort of seeing countries displayed in a particular way. But what it's always doing is it's underestimating the size of countries that are at the equator. And as we get further from the equator, it's really distorting the size of things. So this is a kind of fun tool to kind of take a look at and sort of, you know, ask yourself how different countries around the world sort of compare to each other in size. And the main thing to know is just that whenever we are using a coordinate reference system, it is going to be skewing things, and it's always just going to be a projection and a representation of the size that we look at. Okay, so coordinate reference systems become important often if we're combining multiple different like shape files. We want to make sure that they're at the same coordinate reference system. And this can often be important, especially if we're like measuring lines between things. We sometimes need to take into account like the curvature of the Earth, or we need to make sure that they're in the same projection so that we can estimate them correctly. So one of the ways we can check the coordinate reference system is using a function called st_CRS. And we can check this for the North Carolina data. And what we can see is that it's got a coordinate reference system that's NAD 27. And this corresponds to the North American datum, which was something that they created in 1927. And then it's got a little bit more information about the ellipsoid. It tells us that it's using sort of Greenwich as the kind of center, and it's telling us some other information about the coordinate reference system. Now, coordinate reference system, there's very, very many of them. They're very complicated, and I don't fully have a grasp of sort of all the different ones and what they mean. But what's important is that this is the way that you can check what your coordinate reference system is, and then you can Google it and look it up and think about sort of what different sort of reference systems you have and how you want to match them up. So you can transform a coordinate reference system using st_transform, and often we're going to want to transform a coordinate reference system just so that the spatial files we have match up, and then also so that we can then be sort of looking at things the right way. We might also be thinking about how we're going to be plotting them. So again, we have all those different coordinate reference systems. They're going to show sort of the world in a different way. We can think about sort of how we want to sort of project them and how we want to sort of represent them. Now, one thing is that it's tricky to know sort of what coordinate reference system to use. So one that is commonly used, and mainly because it's used by a lot of like GPS technology, so probably the coordinate reference system that our phones are using, probably the ones that a lot of like navigation devices are using, is the EPSG 4326, which is also known as the WGS 1984. And the WGS 1984 stands for the World Geodetic System 1984. It's often used in cartography that's used by GPS technologies. The main reason we're going to be using it here is because it's the default in Leaflet. So if we want to transform a coordinate reference system, we first take our data set because we want to save the results. We're then going to use the assignment arrow, and then we'll do st_transform. We put the name of our data set, and then here we can specify the coordinate reference system that we want. If we're specifying the EPSG 4326, the way we do that is we do plus init equals EPSG : 4326. We can then check our coordinate reference system again, just to make sure that that change has happened. And then here we can see the user input, and we can see that we've gotten it onto the one we want. So now within the tutorial, if you scroll down, we've checked the coordinate reference system for North Carolina. Let's go ahead and check what it is for the Nigeria data set. So if I'm going up here, my data set's called Nigeria_DF. You can take, I've left in the tutorial a number of sort of links that you can fill in. So we can try to put in Nigeria, DF, and then we can go ahead and check what this one is. And we can actually see that in this case, the data that we get from the RGeoBoundaries package is already in the WGS 84 projection. So we actually don't need to transform it. It's already in a type that's going to work really well for when we're looking at Leaflet. So we're all set there. If we did want to transform it, we would sort of do the same thing as before, and we could check whether this worked or not by filling in the blank, and we could fill this in as ST_CRS. Now, one of the things I often tell my students is that I'm someone who never remembers things off the top of my head. So anytime you're within R and working with new packages, you can always find out what a function is by doing the question mark and then putting in the name of the package. So if I do question mark ST_CRS, it's going to open up the help file for me. And here I can find out a little bit more about what the function does. So here I can see that it's saying it's a retrieve the coordinate reference system from an object. So it's going to retrieve the coordinate reference system from an SF or an SFC object. It can also be used to set or replace the retrieved coordinate reference system from an object. It gives us a couple examples of how it's used. So it's got some different, it can be used for a lot of sort of different options. And then we can see here what arguments it takes. So X is going to be like a numeric character or object of class SF. We can specify some different like parameters in here, and we can also specify like a value or a name or other things. One of the nice things is that whenever we're looking at a help file, if we go down here, we can see different examples. So one of the things we can take a look at is another way to set the coordinate reference system is we could take our SF object and we could do ST_CRS SF and then equals 43226. So there's some different options that we can just find, and we can check what each of those functions do anytime we have like a question about them. Okay, so we've mainly chosen that coordinate reference system because it's what Leaflet uses. We've seen sort of how we can transform things. Next, we're going to get into how we make the Leaflet map. So just to recap, so spatial data are represented as points, lines, polygons, and rasters. Points, lines, and polygons are all GPS coordinates. They're just, in the case of lines, GPS coordinates where we have a line connecting it. In polygons, GPS coordinates where we have lines connecting them, and it starts and finishes in the same place. And then rasters is more sort of the gridded data that we work with, where we have, again, GPS coordinates that are going to be specifying where the corners of our grid cells are, but then we have a single value. So for instance, we might have like gridded population data or temperature data. Those always occur in rasters. And because rasters are within those sort of squares, you can actually do a lot of the same things you would use for working with images in terms of how we deal with rasters. The spatial features are going to be stored as the geometry, and this is always going to be a column within our SF object. A good way to access administrative boundaries for several countries is using the RGeoBoundaries package. I'd be interested when you're looking at this data to see how the data matches up, because I think one of the challenging things is that a lot of packages are often including only like the English names of administrative units, and there might also be discrepancies in terms of not being updated with like the latest data that a country has, or it might also have an older name or a different name. So it's always good to just double check to see whether the names of the administrative units and also the outlines actually make sense for the country you're working with. Whenever we're working with spatial data, we need to take into account the coordinate reference system, and the easiest way to check that is using the ST_CRS we can use that to retrieve the coordinate reference system. And then we can use the information in our data set to create the visual elements of our map. So we can choose sort of to color the administrative regions by one of our variables. And this is one of the ways that we'll be using maps to present data. Okay, so next I'm going to move on to the introduction to Leaflet mapping. So Leaflet is one of the most popular open source JavaScript libraries for interactive maps. So the Leaflet package that we use in R is actually a tool where we can write sort of our code to interact with this JavaScript library. Just like ggplot, it's built in layers, and it's built on top of a base map. So we can have different sort of underlying maps depending on what context we want to give to our data. And it'll be built sort of up in layers. So just like when we're making a ggplot, when we're making a leaflet map, it's going to start with the call to the leaflet function, and then we're going to be specifying our data. So here we've got leaflet data equals NC. So far, all we have is our plotting region. Nothing's been plotted yet until we specified something similar to the geometry for ggplot. But one of the early things we can do is we can add our base map. So the way we add our base map is we can use something called add tiles. By default, this is going to give us sort of a zoomed out map, but already we can start to sort of interact with the data, and we can see that for our add tiles, we can go ahead and we can sort of zoom in on Nigeria, and you can already see that it's got a lot of sort of detail for some of the things that we're looking at. So if we go into Lagos, if we keep zooming in, we're going to see that actually it has some detailed data on some of the different sort of roads we have, and we can already see sort of some buildings, and we can take a look. So it has like the name of different sort of roads and expressways. It's got Pan Atlantic University. It'll have sort of other things sort of within here. So that's all just within the base tile map. You can see down here it says Leaflet and then OpenStreetMap. So it's using OpenStreetMap as the base, and we can see sort of some data and information about what we're looking at. Okay, so note here that layers are going to be added using the percentage greater than percentage sign in Leaflet, whereas whenever we're working with ggplot, it's using the plus. And note that this the pipe symbol that we're seeing when we're adding layers in the Leaflet map is different than what we're using in the tidyverse package. In Leaflet, it's a way of adding on sort of different layers. In the tidyverse package, it's a way of kind of creating pipelines. So they're ever so slightly different. So we've added our layers. Now we want to sort of show what our data looks like. But before we do that, we might want to set like the view. So when someone comes to our map, what do we want to show them? So in this case, I'm showing data about North Carolina, which is right here. And so I want to set up the map so that in the midpoint, I have North Carolina. And because North Carolina might not be such a well-known state outside of the US, I also want to include sort of some of the states around it so that it gives a little bit of context in terms of like where it is. So it's your turn. I've left a place within the tutorial. Here you'll notice that for the view, setting the view, I've specified like longitude and the latitude. What I often do to retrieve the latitude and longitude is I usually just open up a Google Maps page. And then what I'll do is I'll navigate to like the place that I want. So currently I'm giving this workshop from France. So for instance, if I wanted to give sort of like the location of where I was, I might sort of put a little point there. You can see here that down at the bottom, it's giving me first the latitude, and then it's giving me the longitude coordinates. So I could take those, and if I wanted my map to be centered where I'm here, I could just find out sort of where that midpoint is. And this is often how I will choose sort of like where I want things to be located. So here I've got a couple of suggestions for things you could try. You could try setting the longitude to 8.13 and the latitude to 6.88. And then I want you to try setting different values between 0 and 10. This is going to control like the zoom level of the map. So if you wanted to sort of have things more zoomed out, or if you want to have things more zoomed into your area, you can go ahead and try that. And if you go down into here, you can see that we're at this point. We can try to update that map by including some different latitude and longitudes. So I'll take a minute or two and have a go playing with that. While you're working away, I'm going to try updating this map to that point I just found. So for set, we have 43.4 and then 3.66. So I'm going to try updating my map to those. So I've got 3.66 and then I've got 44.4. And if I go and do that, I'm getting an error, but I have a feeling it's just a temporary one. So I can see that I'm in this region. I'm in the region of like Occitan in France, and I can go ahead as well and I can play around with my zoom. So if I make it a smaller number, I'm zooming out. If I make it a larger number, I'm zooming in. And we can start to see sort of a little bit more about some of the national parks, some of the different places where we're located. And just as a reminder, so the ones you can try for longitude and latitude is 8.13 and then 6.88. So I will also put those in. So let's see, 8.13 and then 6.88. And that's at a zoom level of 8. I might change my zoom to level 4 and rerun things. Cool. And so we can see that those coordinates will take us somewhere where we can see Nigeria, and we can decide if we want to have things more or less zoomed out in those areas. Excellent. So changing those are going to take us to here. And we can already sort of be like seeing a lot more of different places. So that's setting the view. The main things to be thinking about is, you know, what is the expanse of your data? If you're showing the data for the whole country, you probably want to picture the whole country there. You might want to include sort of more of the surrounding area to give a little bit more context. And we're going to see in a minute how we can choose different provider tiles depending on what we want the context to be. So add provider tiles. If you look here, we can change from add tiles to add provider tiles, and then we can specify like what the provider is. So for instance, like here, I can do providers $ same in terrain. That's going to show the terrain. So it's going to show more of the habitat and sort of natural features. So as someone who is formed as a biologist, oftentimes, depending on the species that we're studying, we're going to be wanting to sort of show something about the forest or the environment or the ocean that the animal's from. So if we go ahead and zoom in now on North Carolina, you can see that we can actually see like some of the names of the mountains. We can see the ridges. We can see sort of like a lot of different things. If we go up to sort of the state where I'm from, you can see this is the Appalachian Mountain Trail. we get a little bit more of a sense of sort of where there's sort of higher mountains and higher peaks. So one of the kind of neat things about Leaflet is that it actually comes with a lot of different provider tiles. So one of the ways that we can change these around is that first, when we have the add provider tiles, we're going to have providers $sign. And then if you click the tab key on your keyboard, it's going to open up all the different options you can use. Now, many of these are available, but one of the things to be aware of is that a few of them do require you to create sort of like a free account and download the API. So if you try one and it doesn't work, try sort of like another one. So I recently gave this workshop in France. So one of the ones I showed was you can change it to OpenStreetMap .France. If I go ahead and run that map now, you're going to see that now instead of it being North Carolina, we've got like Caroline du Nord. And so all of the names now, especially of like the different sort of countries, they're now sort of in French. So they've got French labels. We can see sort of like how the things come up. And so this is also a way of sort of, again, depending on who your audience is, depending on what like the main languages they're speaking, you might want to change your different sort of provider tiles to something else. So now, did someone have a question? Okay, so another one that I really like as a marine biologist is, again, if I press the tab key within the providers, one of the ones I really like is there's one called Esri ocean base map. And if we go ahead and run that one, you can see that what's neat about it is you can actually see sort of where like the continental shelf is. So for instance, here in Maine, we've got lower sort of like slightly deeper waters in this area, a little bit further from the coast. You then go to George's Bank. George's Bank is a really important fishing ground, especially historically for cod. And then you can see that things really drop off and you get a much sort of deeper area where the ocean goes down to like 5,863 meters. And if you continue to zoom out, you can see all of sort of what the ocean looks like. So we have the Mid-Atlantic Ridge. We've got some really sort of deep areas, and you can explore sort of what that looks like all across. Now, if we were going over to more into the Pacific, some of the like deepest areas is the Mariana Trench, and we can start to see sort of like where some of those are. So that's the Tonga Trench. I think the Mariana Trench is sort of like near there, but it's a really neat way to sort of explore things like the ocean. And if you were studying a marine species, something like the depth at which that marine species is at can become like very important. There's also some provider tiles that are just like a little bit more for fun. So for instance, we click tab again, we can go ahead and take a look, and there is one that's called like Stamen watercolor. So if you just want to create like a pretty map, you have this one that which looks at like the sort of map of the world, and it just shows it with these like watercolors. And you can also combine provider tiles. So for instance, one of the things that you'll notice with this map is that it doesn't actually have any labels. So one of the things we can do is we can actually combine multiple layers. So I can do the watercolor, and then I could do the add provider tiles, providers. I'm going to do the $sign, and then I'm going to tab. And here, I think there's some options for just adding labels. So maybe if I do terrain labels, and then I'm going to add this as just like another layer in my map. Go ahead and run it. We can see if it comes up. Now you're going to see is that I've got that kind of nice watercolor, but now I've actually got some labels and it's giving me like it's giving me the names of the different cities, but it's also giving me like the shorthand for a lot of the states. So for instance, Maine is specified as like ME. So you can combine sort of multiple layers together and you could add sort of different things onto there if you would like. Cool, so there's kind of nice ways that we can add sort of some different layers. We still haven't plotted any of our data, but we've got some nice sort of different base maps that we can try out. So the next thing is that just like when we're making a ggplot and we're specifying the geometry, here what you can do is you can add polygons. Add polygons is going to add, it's going to look for the geometry column within our file, and it's going to give the outline of those areas. So now we can see that we've got North Carolina on here, and we can see sort of the outline of each of these regions. So I've left some blanks sort of within the code. So if you want to try creating the map now with the Nigeria data, you'll sort of see as you scroll down, although this is not sort of showing up. Let me just refresh real quick. So sometimes I find that RStudio doesn't show everything that we would want. So I can refresh it, see it again. And here, I'm going to navigate down. You can also navigate through these things. So I might go to like Nigeria first leaflet. And you can see here that I've provided sort of some areas where we can specify the longitude, the latitude. You can also add the data. And then we also have the polygons. So you can go ahead and I'll give everyone a minute or so to try to fill in those blanks. And just remember that before, when we wanted to take a look at Nigeria, if you go up here, you can find like the longitude and the latitude. And then we also want to specify like the data set that we have, but we can go ahead and do that here and try to produce that map. So I'll give everyone a couple minutes. Okay, I'll also start to fill in some of the blanks. So here I'm going to specify that my data set, Nigeria_DF, that has the data I'm looking at. The longitude and the latitude I wanted was 8.13 and then 6.88. So I'm going to do 8.13, 6.88. I'm going to go ahead and run that. So I think I'd probably like to decrease my zoom a little bit because I'm not able to see sort of all of Nigeria. So I'm going to change that to 4. You can also do Control Return and use that as a way to look at it. Again, we're just seeing the outline of our regions, but we can start to sort of see where the different departments are that we have within our data set. So that's all looking really good so far. Okay, so the next thing is that unlike ggplot, where Leaflet, where it will sort of like choose a kind of sensible color palette for us, when we're working with Leaflet, we often have to create the color palette ourselves. So in terms of when we're creating a color palette, some of the things we want to be considering are are the variables we showing, are they numerical? So are they some sort of number, or are they categorical? So for instance, if we were using something like a category, like which football team different departments in Nigeria supported. Now, depending on sort of where you come from in Nigeria and which football team you support, you might have strong feelings about which one is better than the other. But because they are categories, they're actually something that, unless we have outside information like how many matches the team won or how many matches the team lost, there's nothing actually to say that one of those categories or one of those teams is better than the other. So we just want to be thinking about sort of what we're going to be showing on our map. And then we're going to be thinking too about like who is our audience. So for instance, if we're maybe using something where we're looking at health data, oftentimes we associate red with something being bad, like something being like a big health concern. So we might be thinking about sort of what colors it makes sense to use depending on who we're sort of communicating with. And then also what story are we telling with our data? So for instance, if someone asks you that like we only have funding to run programs in 3 departments that were the hardest hit by COVID cases, we might want to sort of choose our colors. So we're really just highlighting sort of the 3 sort of worst areas. We might also want to think about showing sort of like, if you're looking at maybe more of an economic statistic, it's like which areas are overperforming, like they're doing really well, they're bringing in a lot more revenue, and then which ones are bringing in less revenue than what the national average is. We might want to use something that's sort of more of a diverging color palette. So it just depends sort of what we're looking at. One of the resources that's really useful for when we're thinking about colors, especially on maps, is there's a website called colorbrewer2.org. And so if we open that up, we can see sort of some different colors here. And we've got some options. So we can take a look at like sequential color palettes. So this one could be sort of darker to lighter, sort of going higher, or we might sort of look at like diverging color palettes. So the ones that are over and above sort of white are better than average. The ones that are left are sort of lower than average. We can sort of start to sort of see like which ones are high, which ones are low. One of the handy things we can do is we can just select like only show the colorblind friendly palettes so that our plots are going to be as accessible to the most number of people. We might use sort of some color thing like usually we associate red with heat and then blue with cold. So again, when we're looking at sort of climate and which areas are sort of getting hotter or less hot, we might sort of look at those different variables. And one of the things you can do is you can explore, for instance, like if you were to make this plot with roads, if those roads were red, if you had city names on there, you can take a look at sort of some of the different labels and see how that would work and how that would sort of show up on your map. So those are all things we can consider, and Color Brewer can be a really good way to check those out. And it will also give us the hex, which we can use for the colors, and we can export those colors once we decide on a color scheme we like. You can also choose between like whether you have the number of data classes you have. So for instance, let's say there was like eight football teams within Nigeria, or maybe we go for 5 or 4 football teams, 4 main football teams. This qualitative color palette is a color palette that is just used to sort of distinguish different areas. It's not actually being used to sort of rank them in any way. So we can look for sort of different colors depending on what our application is. So is it numeric? Is it continuous? Is it a measured data? Can it have infinite values within a possible range? Is it discrete? So observations can only exist at limited values, so often counts. So for instance, often when we're looking at something like COVID data or population data, we're talking about sort of number of people and number of individuals. So those can be some things to look at. For categorical data, we can have nominal data, which is unordered descriptions. So for instance, football team A, football team B, football team C. You could also have ordered descriptions. So like high, medium, low are actually ordered descriptions. You could also have binary variables that are mutually exclusive. So it can't be, if it's one, it can't be the other. So our color blue includes all these different palettes, and we can check them out using display.brewer.all, and we can specify the type. So like type equals sequence, and then look for a set of colorblind friendly. And these contain the same colors that we would see on the others. We can also look at like a diverging color palette as well. So in terms of how we specify the color palettes that we're looking at, we can define, first we want to look at sort of the numeric variables and what things are ranging from. So for instance, here we've got minimum 248 hertz, maximum is 21,588. So we would probably want to sort of split our data up. In this case, I've specified bins that are the size of 5,000. And we can go from 0 to 25,000 up by 5,000. And that's going to give us the split for our data. And then the way we create our palette is that we can specify it with like the color bin function. And here, if we look back at sort of our different palettes, we have sort of different codes depending on what how we want to sort of show our data. So in this case, I've chosen one that goes from orange to red. So I'm going to specify which color palette I'm talking about. The domain is going to be what variable we're translating into those colors. And then the bins are going to be giving sort of the spaces to break it. So anything below 5,000 is going to get this color of orange. Anything between 5,000 and 1,000 is going to get this different color. So there's some different options that we have. And within the code book, I can give you, I've given you a space so that you could try this out for the Nigeria data, looking at the total population, which is a lot bigger. You could sort of take a look at sort of what size you might want to make that. So then once we've specified the color palette, we can add this sort of within add polygons. There's a number of different arguments we can specify. And so some of those are like the fill color. We can also choose like how opaque, how transparent we want it to be, which goes from between 0 and 1. We can choose the color we want the outline of the borders to be. We can also choose like how opaque we want the border to look, if we want it to be a more solid color or less solid color. And then we can also choose the weight, like the size of the line. So there's a number of different things we can do to sort of like look at the appearance. One of the nice things about maybe making it a little transparent is you could still see the labels underneath. We now have a sort of nice plot where we can see like the different levels there. So there's a number of sort of different things we can sort of take a look at. And then, so those are some of the different options we can change. You can change those around. So you can, again, sort of like customize and change and sort of see what works with the background you chose and like the data, and take a look at sort of some of those options. So again, like within the notebook, you can take a play around with those and try out some different options. Could I get a time check? Is there another presenter coming after me, and what time will they be starting at?
There is no presenter after, but we're hoping that the participants can try to replicate some of the things we've done during this session after yours.
Cool. There's no session after me?
No, it's just a group exercise.
Okay, perfect. All right. Well, you just let me know if I'm sort of carrying on too long, and if you need a break. So let me keep me sort of posted.
Like how much more time do you need?
Maybe another 15 minutes, if that would work.
Yeah, that's fine.
Okay, perfect. All right, I'll continue along and go through. So, all right, we can customize and we can sort of change some of the ways that things appear. The way we can find out sort of what things that we can change is we can use the !@ add polygons. So we can change, and we can also see sort of what each of these values correspond to. We can also add something called highlight options, which has options for highlighting the shape when we move our mouse over it. So for instance, if we were to add some highlight options to this plot, which we'll see in a moment, it's going to pop up with different things. But one of the things that's useful is sometimes assigning our plot to an object. So the same way that we would save our data set, we could save our map at a particular point, and then we could build off of that map. So for instance, here, I'm going to save my map into something called M1, and I'm going to take the first 3 lines, which were the leaflet, adding the provider tiles and setting the view. And I'm going to just save that into an object I called M1. Then if I want to build on that, I can just go ahead and start off with M1. That's going to contain all of those pieces above. And then I can add some other things like the polygons and the different things I'm specifying. So that's a really handy thing. Say, for instance, if you know you're going to have to create several of a map, but you are going to always start with the same base map, and maybe you're only going to specify a couple of different pieces, you could save the objects sort of part of the way through. Okay, so when we're adding highlight options, one of the nice things is that this now, as we're scrolling over things, it's going to highlight the region that we're looking at. And this is nice because it sort of gives the user that feeling that there's some interactivity with the plot, and we're looking at sort of a number of different things. And so we can set things like bring to front equals true. That's going to sort of bring it up. It's going to change the fill opacity so that maybe it's solid. It could change the outline to be blue. We can make the outline thicker. All of these things can just be things that we want to specify and sort of add to. The other thing that is really helpful is that we can actually add labels, so we can be giving information about our data. The way that we're adding labels is using a package called HTML tools. So HTML tools, anytime we're working with a website or an HTML document, it's going to be using HTML. What function we use from HTML tools is one called sprintf. Sprintf is going to return a character vector that contains a formatted combination of our text and our variables. And we're going to be using some HTML in order to style the text that we're using. So one of the things that we will want to do is we might want to bold one of the elements. So whenever you see strong, that's going to be how we bold things in HTML, and it needs to happen on either side of the particular element that we want to bold. You'll also notice that we have BR means a new line. So maybe I want sort of part of my text to be on this line and then some of the text to be underneath. And then we have something that we're also going to include called the PHP, which stands for Hypertext Preprocessor. It's another type of computing language. And the main reason we're going to be using that is because we can use it to specify variables within our data set in our labels. So here, what you'll notice is that we've got a %s. This is a placeholder for a character string. So remember that in the North Carolina data set, our county is a name. And so whenever you see a data type in R that has quotes, it means it's a character. It means it's a character string. And so the %s is just a placeholder for that. And then we have the NC births, 1974, %g is a placeholder for a numeric variable. So what we're saying is here, if I was to read this out, I'm saying I want to bold the county name. I want to put a new line with the BR. And then I want to report the number of births, and I want to follow it by the text births. And so I'm going to be taking that from the sprintf function. I'm going to be passing it in through an lapply that's going to change that to HTML. What this looks like is it will take all of our sort of columns and create a label for each one of our things. So now we've got the county Ash, and then we've got the number of births in Ash. So a good way to sort of see what this looks like in practice is we can add, as one of our arguments for add polygons, label equals label. Now, as we go over our map, you can see that I've got the area. So now I've got like Johnston, and then I can actually see how many births are in that area. So again, I've got sort of the color that's indicating like the level and the number of births, but now I've also got a label along with it. And you can customize your label based on the information that's going to be useful and it's going to be helpful for your map. So we can do that. The other thing that's helpful is to add a legend. So again, here I've saved like everything into M1 again. And then here I'm just adding a legend. We can specify the position. So if we want to put it on the bottom right, we're going to specify like the palette that we're using. So remember, we defined a palette called PAL 74. And then we've got the values. So like which is the column and what are the values corresponding to. And we can add a title, and also we can choose whether we want to have it sort of transparent or opaque. And so now we can sort of like hover over things. We can get the information. We also now have a nice legend that as we zoom in and out are in that area. So we've created sort of a nice map. It's got a lot of our data, and we've got those labels there. So the other part I wanted to briefly mention and sort of talk about is that oftentimes we might work with like a shapefile, but more often than not, we often have data sets that have two columns, one that gives a latitude coordinate and then one that gives a longitude coordinate. And we can actually use this information just as it is. So this is a data set that's defined in the tutorial that's called work. It has some different institutions that I've worked at for different projects. And here we've got, did someone have a question?
No.
No? Cool. So here what we have is you can see you've got different variables. So we've got location, institute, work, and then we've got a latitude and longitude, and then we've got the type of sort of work it was. So now if we wanted to specify this with our leaflet, we can add sort of, the provider tiles I want. In this case, I went with the watercolor, and then also I also went with the same in terrain labels. And then if we're just like when we're specifying sort of different geometries, if we're making a point plot or if we're making a line plot and ggplot, if we're creating something where we have like locations, we can use something called add circle markers. The difference here now is that we're giving the tilde and then the name of the column that has our longitude coordinates, comma, tilde, and then the name of the column that we have our latitude coordinates. So here we've got sort of like a number of different things. It's not looking very fancy like so far. We would need to customize it further, but we can see sort of all of those different locations and put those points on there. So one of the ways we can think about ways we can change is we can use double question mark and then look at like add control. And one of the things we could do is we could add like cluster options equals marker cluster options to our map. And if we go ahead and do this within our data set, you can see like adding those cluster options. Now, as we zoom out, we've got things so that if you have a lot of like points, it can actually summarize and cluster things. So you can again get a sense of like how many cases of COVID are we talking about? How many, sort of different people bought this particular item? You can get sort of a sense of that. And the cluster options are a really good way if you're working with lots of points of data and you're trying to get sort of a view. And then as you click on things, so for instance, if you were to zoom in, you can then get those different locations. But as we zoom out, we get sort of like those bigger clusters happening until we get sort of, larger and larger clusters. So it can be a handy way to look at our point data. Again, if we wanted to add labels here, I'm just going to be specifying the work institute. Again, it's a name, so I'm using %S. I can create those labels, add them to my add circle markers. In this case, I'm specifying them as a pop-up. So if we go just here, I'm specifying them as a pop-up. Again, I'm just putting that tilde and then labels. And then now if I click on places, I can see sort of what the name of the institute was. So this can be another way that you can add things to your map. In this case, rather than it being something that we hover over, it's something that the user clicks on. So you can decide if you want to have something as a pop-up or if you want to have something as a label, and you can add sort of different pieces. So I'm going to stop there. So just a quick recap is that remember that leaflet maps are built in layers using the percentage greater than percentage symbol. Every leaflet map is going to start with a base map, and we can customize this by setting the view and choosing different provider tiles that are going to give context to the data that we're looking at. We're going to choose the geometric shape depending on our spatial data type. So for instance, like add polygons or add circle markers, depending on sort of what type of data we're working with. When we choose a color palette, we need to think about our data types and also our audience. We can also add interactivity to our plot using things like highlight, which brings sort of areas to the front, and also labels or pop-ups. And there's a lot of sort of different things. So in terms of things you could do after this workshop to sort of keep working on things, you could create a new map with the births from 1979. You could change around, sort of customize different visual elements of the plot. You could create a new set of labels for the leaflet map with points. You could check out a short tutorial on more about how to sort of join up sort of spatial information. You can also continue on with the Nigeria data set that's included and see sort of what things you could customize and take a look at. The resources like for this, you can access sort of the slides through the link. There's a really useful leaflet tutorial on lots of different things you could do with RStudio. And this also includes sort of like working with raster images, and it's got a lot of different like code and things that you can try out, so that if you wanted to sort of add different things or learn a little bit more about like the projections, you can try out sort of a number of different things to add. There's also a really useful free open source book called Geocomputation with R, which is, again, if you're needing to do some more sort of calculations or things with your spatial data, that can be really useful. A lot of the AfriMap R tutorials that introduce sort of spatial data in R, getting data into R, or joining spreadsheet data, all of those are going to be really useful for like how you work with and manipulate and work with sort of different things. The R spatial data github.io is really useful in terms of different sort of data sets you could access. So whether it's like administrative boundaries, OpenStreetMap data, population, elevation, temperature, rainfall, humidity, a lot of things that are going to be linked to some of the UN Sustainable Development Goals and those things that you might want to look at. That has a lot of like useful information there, and tutorials on how to access it. So for instance, like here with vegetation, it teaches you how to work with the Modis library, and there's a lot of like different useful information and tutorials that you could use. And then lastly, one of the places that I often look for data is the Humanitarian Data Exchange. You can look for sort of data on different places. So if you were to search for Nigeria, you would have sort of a lot of information on like roads. You can specify sort of here what type of files or formats you're looking at. So if I'm looking for a spatial file, I might click on the SHP file. That's going to give sort of some things on like roads, subnational administrative boundaries, settlements. All of these things can be really, really useful depending on sort of the project and the context and things you're taking a look at. So I recommend checking any of those out. And I'd be happy to answer any questions that you may have. Well, feel free to reach out. Like I said in the slides, like my, contact information is there, and the slides are available to go through things. The other thing I would always say too is that a really useful thing is always just to start with a sketch of what you're wanting to create, and then you can think about sort of the different elements you want. But best of luck, and it sounds like you all have a great workshop and a great sort of summer institute that's been set up there with lots of interesting discussions and tutorials. So I wish you all the best